All right, here's a video for notes 1-4 applications of similarity. So in notes 1-2, we learned that if two triangles are similar, we know that their sides are proportional, which means we can set up this ratio and solve for missing sides. In this lesson, I'm also going to talk about this method called indirect measurement, which is a way that we use similar triangles to solve for missing side lengths. So for instance, there's something called the mirror method, which means that you put a mirror somewhere between you and a tall object, and it creates two similar triangles that kind of face each other. The reason they're similar because at angle, the angle coming off of the mirror is going to be congruent, and then the angle for the object to the ground is going to be perpendicular, 90-degree angle. So then it allows you to set up similar triangles. So for instance, you can do, if we call this X and we call this Y, and then we call this A and call this B, we can set up a ratio X over Y equals A over B. Okay, or you can do X over A equals Y over B, but basically you have two similar triangles and then you can cross multiply and solve. So same thing with the shadow method, it's just a different method of indirect measurement. What you do is you measure the length of a shadow of an object and you measure the length of a shadow of you, and then you use your height. And again, you create two similar triangles. So we have X and Y, which is the height of whatever you're measuring, and then your height over the shadow. And then we have two similar triangles and we can set those up as well. We can do height over height equals shadow over shadow. So let's look at a couple examples of applying kind of what we learned about similarity. So here it says campsites M and N are on opposite sides of a lake. Okay, so they're referring to M and N. A survey crew made the measurements shown in the diagram. First of all, we need to figure out how the triangles are similar, and then we need to determine the distance between the two campsites. So we're solving for the length of MN. So this is what we're solving for. So first thing we need to do, we have to prove that the two triangles are similar. So we can't solve for this side until we determine that the two triangles are similar. Well, looking at the given information, I have three sides of this triangle, but I only have two sides of this triangle, which means we can't use side, side, side. So we're probably going to be able to recognize that we have a vertical angle here. So I'm just going to say that angle L is congruent to angle L. And the reason is that they're vertical. Okay, then I can set up my ratios of sides. So in this case, we do have to match up the smaller sides. So looking at these two, I have the 55. That's going to go with the 44 because those are the two smaller sides. We're essentially ignoring the 50 because it doesn't have a corresponding side. And then that means the 70 and the 56 are going to go together. So checking my ratio, the sides have to be proportional. I'm going to do 55 over 44 equals 70 over 56. So to check that those sides are proportional, we need to use a calculator. So 55 divided by 44 gives me 1.25. 70 divided by 56 also gives me 1.25. So here, this tells me that the included angle is congruent. And this right here tells me that their sides are proportional. So we can say that these are similar by side, angle, side. And because they're similar, now we can use a relationship that the sides are proportional to solve for this missing side. So setting this up, I'm going to do x over 50 equals, and then you can pick and choose. So you can either use this ratio or this ratio because they're both equal 1.25, so they're exactly the same. 55 over 44. And then we're just going to cross multiply here. So we have 44x equals, and then I'm going to do 55 times 50. Get 2750. And then divide both sides by 44. So divide by 44. You get 62.5. The word problem should have word answers, which I'm going to write this as a sentence. So the distance between the two campsites is 62.5 meters. All right, So here's another example, again, just applying what we know about similarity. So it says a 36-foot support wire for a 12-foot tall street light runs from the top corner to a point on the ground. So this right here is the support wire, and we know that that is 36 feet long. Okay, we also know that our street light is 12 feet tall. And then it says the length of the wire from the top of the building to the top of the street light is 16 feet. So from here to here is 16 feet. And we want to know how tall is the building. So what we're solving for is this length right here. So I'm going to go ahead and put X there, or you can use whatever letter, it doesn't matter. Okay, so now that I have my picture drawn, now I see, okay, essentially this is two triangles, two overlapping triangles. I have my big triangle, and I have my small triangle. Okay, so now I'm just going to label what I have. Well, we know that this is X, and we know that this is 36. And then in my smaller triangle, I know that this side is 12. And here's where we need to be careful. This length right here is not going to be 16. 16 is from the top of the street light to the top of the building. So to get this length right here, we're going to have to subtract 36 minus 16, which is going to be 20. Okay. Now we can set up our ratio. So x over 12 equals 36 over 20. So x over 12 equals 36 over 20, and we're going to cross multiply. So 20x equals, and then 36 times 12 is 432. Okay, and then we are going to divide both sides by 20. So 432 divided by 20, we get 21.6. All right, so then our final answer, we're going to say the building is 21.6 feet tall. All right, example 3. Here it looks like a mirror problem. So it says to measure the height of a flagpole, you place a mirror 60 feet from the flagpole. Oops. Okay, so the mirror is 60 feet from the flagpole. So that's going to be here. It says you step back until you see the top of the flagpole. So you step back and then you say that's 10 feet. Then it tells us the height to your eyes is 5.5 feet. So height we measure up and down, so this is 5.5 feet. And we're solving for the height of the flagpole, which we'll call x. So now that we have it labeled, we have two similar triangles. So we're just going to set up our ratio, x over 5.5 equals 60 over 10, and cross multiply. So 10 times x is 10x. 5.5 times 60 is 330. Divide both sides by 10. So I'm going to say the flagpole is 33 feet tall. All right, last example here. So it says, instead of using a mirror, Billy decides to use a shadow to measure the height of a flagpole. The light pole shadow is 23 feet tall. So this is a shadow problem, and when we have a shadow problem, we have two triangles that are, one's big, one's small. They face in the same direction because that's how shadows work. So let's just fill in the information. So it says, the light pole's shadow is 23 feet long. So shadows are on the ground, so that's going to be this measurement. Then it has the Billy, who is 6 feet tall, so that's going to be right here. Then we have Billy's shadow, which is 13 feet, so that's going to be down here. And then we have the height of the flagpole, which is what we're solving for. So again, once our picture's drawn, fairly easy setup. X over 6 equals 23 over 13. And we're going to cross multiply. So 13x equals 23 times 6. Which is 138. And divide both sides by 13. Hold on, something seems wrong. Oh, it's 13.5. Oops, sorry. This should be 13.5. Say my number seemed off a little. So again, 138 divided by 13.5. There we go, 10.22. So I'm going to say the light pole is 10.22 feet tall. All right, now for a couple of the practice problems from the homework. So it says triangle EFG and QRS are similar. So I'm just going to sketch a picture here. So EFG. QRS. So it says the sides of EFG are 144, 128, and 112. And the length of the smallest side of QRS is 280. So the smallest side I'm going to put down here, this is 280. Okay, obviously this is not drawn to scale. We want to know what is the length of the longest side. Well, the longest side is going to be the side that matches up with the 144. Okay, so we know that these are the small sides. So those are going to go together. And we know that 144 is the biggest side of the first triangle. So that's going to match up with the biggest side of the second triangle. All right, so now we're just going to set up our ratio. So x over 144, so those are the big sides together, equals 280 over 112. So now we cross multiply. 112x equals, and then we're going to multiply 280 times 144, which is 40320, and then divide both sides by 112. We get 360. As a sentence, I'm going to say the longest side of triangle QRS is 360. All right, here's another problem here. So it says Carla looks from a height of 15 yards on top of her apartment building. She lines up the top of the flagpole with a curb on the street, which is 20 yards away. The flagpole is 12 yards from the apartment building. How tall is the flagpole? So luckily this picture is already drawn for us. However, there are two triangles, so I'm going to draw them separately so we can make sure we have the correct measurements. So on my big triangle, I know that this is 15 and I know that this is 20. And on my small triangle, I know that we're solving for the height of the flagpole. And for this bottom part, that's this part right here. We're not given that measurement. However, what we can do is we can do 20 minus 12. So this distance right here is going to be 8. That's going to be the tricky part of this problem. So now that I have my two triangles, it's a fairly straightforward setup. X over 15 equals 8 over 20. And cross multiply. So 20x equals 8 times 15. 120. Divide both sides by 20. 6. I'm going to say the flagpole is 6 feet tall. Or 6 yards, sorry. Pole is 6 yards tall. So this is why it's probably important to measure your diagram with the correct units so you know what your final answer should be, 6 yards.